Hello guys, starting from the problem A, let's open this one. Let me just refresh it real quick. Yeah, so this is quite a simple problem guys. In this problem what you have to do is that you have three options. You are given a permutation P of some length, and your initial counter is C. Now you can do three operations to it. Either add IPI to it, or you can subtract IPI to it, or do nothing, that is plus 0. So what you want to achieve is that C final should not be 1. So how can you ensure that C final is not 1? C final can only be 1 if you add a 1 to it. If you don't add a 1 to it, there is no other way that numbers greater than 1 could generate a 1 by either adding or subtracting, because either you can do 2 times 3 or something. You can try this out, there is no other way. So one of the possible combinations that you can provide is output the numbers from n to 1 in reverse order. So that's what I did here. I inputted n and then I outputted the numbers in reverse order. So for example 4 is given here, so I just output 4 3 2 1. There is no way that these numbers can be arranged to form a 1. That's it. So this was pretty simple guys. Moving to the B question right here. Yeah, you are given an integer n. Construct an array of n distinct positive integers such that for all I, this summation is divisible by ai, or determine there is no such other array exists. So for me this was quite a tricky problem guys. At first I was pretty stuck what not to do with it, and then later I recognized you are given some combinations. See, for there is only one case, that is for n is equal to 2, when you cannot form an array. Other than that, you can take this example. For let's say n is 3, you can take 1 2 3, and after this you can build up upon this. For example 1 2 3, its sum is 6, so this is divisible by 1, this is divisible by 2, 6 is divisible by 2, and 6 is also divisible by 3. Now since this is divisible by this, its entire sum is divisible by 6. So if I add another element which is also 6, then the entire sum would of the new array, what is the new array? The new array is 1 2 3 and the sum of the current array, that is 6. So I add this, so I add the new element as the sum of the current array, which is currently 6. So the array for let's say if there are 4 elements, then the array would become 6. And then what is the sum of this entire array? It is 12. Then what is the sum of this entire array? It would be 24. So what I figured out is that up to 3 numbers you can take these 3 numbers. After that you could just generate new numbers by adding multiples of 6 to it. So I started my sum at 6 and then I added its multiple, not multiple guys, multiplied by 2. Like this is 6, then this is 12, this is 24. After this would occur 48, then 96, followed by subsequent times 2. Alright, so I just remove this. So one impossible condition would be where n is equal to 2, because logically speaking, if there are only 2 numbers and if the sum of both the numbers is divisible by both the numbers, then both the numbers have to be equal or 1. Like let's say one number is a and the other number is b, then a plus b is divisible by both a and divisible by both b. Then in that condition a and b both have to be equal, which here you can see they have asked for distinct positive integers, so that could not be the case. Alright, so that would negate the case for n is equal to 2. After n is equal to 2, we can simply build up upon this array by adding 6 and multiples and 2 multiples of 6, like followed by 12 24, like this, and then just output that array simply. I would just show you what my output would be. Yeah, you can see I entered some new test cases. For n is equal to 1, my code would output me 1. For n is equal to 2, my code would output me -1 through this condition. And for 3, 4, 5, 6, 7, you can see subsequent cases. Like for example 7, the first 3 were provided by me from here only, and then after this the remaining ones I generated by adding 6 and multiplying it by 2 multiple times until my array up till 7 digits, 7 numbers is completed. So that's how I solved the B question. Now coming over to the C question, which was again quite a tricky problem. I think its implementation was quite a headache for me. It was really tricky for me, guys. Also this involved an observation from PNC. So guys, let's first read the problem. Define the alternating sum of a subarray of an array B of length k, like this. Just an alternating sum starting from -b1 plus b2 plus -b3, so on, alternating sequence. You are given a non-decreasing array A of length n such that this either AI is -1 or AI is a positive integer. Find the number of sequences such that the alternating sum of the sequence is 0. Since this number may be very large, output it modulo 10 plus 7. Two sets, these and this, are considered different if k1 and k2 or there exists, if k1 not equal to k2 or there exists a j such that I is known. Okay, this is basic information. Coming over to this. Now guys, I want you to make a observation here. Let's read this test case first, guys. In this test case we are given -1 1 1 2 3. How did the problem statement solve this? We can take an empty array, which means I didn't select any element, which means the sum is 0. I could select 2 ones from here. Again, their alternating sum will be 0. I can select a -1 and a 1 2 here. Also I can select a -1 and a 1 2 here. This one I see, in this test case I selected this -1 and this one and this 2, and the next test case I selected, and in the next iteration I selected this and this, and in this iteration I selected this -1 and this 2 and this 3. Now in this iteration I selected -1 1 1 2 3. Now there are a few observations that I need you to make. See, whenever we take two identical numbers, their alternating sum would be 0, and for that matter take any even number of identical numbers, their sum would be 0. Why would it be 0? Let's say I take 1 and 1. This would get parity -1 and this would get parity +1. -1 plus 1 would give me 1, would give me 0. Similarly, if I had taken 4 ones, then again -1 plus 1 -1 plus 1, this would also give me 0. Now this I can also combine multiple numbers. For example, I have here 2 2s and 3 3s. I can take 2 2 3 3. If I take 2 2 3 3 2 2 3 3 2 2 3 3, it would give me -2 plus 2 -3 plus 3. Again its sum would give me 0. Alternating sum would be 0. Now this was one observation. If I take even number of identical numbers, their sum would be 0. I can also mix them up. I take these two identical numbers and these two identical numbers. Need not take just two numbers. We can also take 0 identical numbers, 2 identical numbers, 4 6. It just has to be even number of identical numbers while also combining them. This is one observation. Second observation is that I can have multiple -1s here. Now what I want you to notice is that I can only have at max 1 minus 1. See what I want. Let's see this example. This is minus 1 1 2, minus 1 1 2. In this example, what is happening is that this minus 1 is getting a parity of minus, so it would become plus 1. This would get a parity of plus, this would get a parity of minus. So these two combined would give me a sum of minus 1, and this 2 with the parity of minus would give me minus plus 1. So this would be converted into 1 minus 1, which is 0. Now what is happening here is that these are two numbers separated by 1. What I mean here is that 2 minus 1 is 1. These are two adjacent numbers. And the observation is that a pair of adjacent numbers cancels a minus 1. This is the observation. This is a pair of adjacent numbers and it cancels a minus 1. Again, this is the same test. This is the same example as that one. Let's see this example. Here also we have a minus 1 and a pair of adjacent numbers. Now coming over to this test case, you might say this does not have all the adjacent numbers only. Yes, this makes sense, because here we have a pair of identical numbers, which really does not make any difference, because it's what do we say, its alternating sum is already 0, so it does not make any difference to the total alternating sum of the array. So we can ignore this. If we ignore this, what do we have? Minus 1 2 3. Again, if we apply the same logic, this minus 1 is getting neutralized by these two adjacent numbers. Now another observation is that we can have multiple minus 1s. Again, there are two cases here. We can have even number of multiple minus 1s, or we can have odd number of multiple minus 1s. If we have an even number of multiple minus 1s, let's say we have minus 1 minus 1 minus 1 minus 1. Isn't it the same condition as this one? There are 4 identical numbers and their alternating sum would be 0. So isn't this the same? These 4 just basically get cancelled. Talking about the case where we have odd number of identical numbers, here we have an alternating sum of minus 1. So in this case, we don't want to neutralize any minus 1, so it means that in this case we just want all pairs, no, not all, pairs of identical numbers, or better word would be even sets including 0 of identical numbers. And in this case we want to neutralize this minus 1. How did we neutralize this minus 1? By taking one pair of adjacent numbers. One pair of adjacent numbers is required. Now since this did not make any sense to the entire sum of the alternating sequence, we would also have to consider this as number of ways. We also have to consider number of ways of selecting these. So I would just copy and paste it here, and this. So what is our final algorithm? Total number of ways of selecting such sequences. What sequences? Whose alternating sum is 0. We have two ways. Take odd minus 1 and even minus 1s. Okay, so odd minus 1s gives me how many ways? Let's see this. When we had an odd minus 1, let's first see even minus 1s. So even minus 1. In this way I require number of ways to select even number minus ones times what would be total number of ways, number of ways to select even minus 1 times the number of ways to select identical numbers times number of ways to select this. It's fine. So and the number of ways to select odd minus ones would be number of ways to select okay yeah. So this this is this giving me that what I'm doing here is that this is the case in which I took even number of minus ones, and this value, this entire value represents how many number of ways exist to get get such a sequence. And for this I have number of ways to get odd number of minus ones, odd times, again since taking identical elements does not make any difference, I would also add this here, like multiply this to the total number of ways, and I would also multiply total number of adjacent elements in the array. Total number of adjacent pairs. Adjacent pairs, what do I mean by adjacent pairs is that both the elements have a difference of 1. For example 1 2 2 3, 1 2 and 2 3, something like this. Now how do I calculate the number of even minus ones? To calculate the number of ways that I can select even minus ones is NCR you might be knowing. So let's say I have n number of minus ones, so total number of ways would be NC0 plus NC2 plus NC4 up till NCn. Now as a mathematical result, this is equal to 2 to the power n minus 1. Again, if I want to get odd number of minus ones, again let's say I have n minus ones. For this also the result would be, for this the number of odd minus ones, the number of ways to select odd number of minus ones would be NC1 plus NC3 plus NC5 up till NCn. Again this is a mathematical result that this sum is equal to 2 to the power n minus 1 once again. So this is one thing. And the second thing is that I want to get the number of adjacent elements. This is quite a simple task. To solve this task, what I did was make a set and make another vector, and then I just pushed all the set elements to the vector and just checked how many elements had the difference of 1. Alright, what other value do I need here is equal pairs. Yeah, the next value that I need here is that equal pairs. Let's take this example. I have here 2 2s, 3 3s and 5 5s. What are the total number of ways to choose equal pairs from all these combinations? From 1 I can take how many elements? 1C0 times, let me just write this for this guy, equal pairs. How many elements would be, how many number of ways are there to select equal pairs from this? What do I mean by equal pairs? That pick even number of elements, pick even number of identical elements, and through any combination. Like for example, you can pick 2 2s and 4 5s, something like this. So what are the total number of ways? 1C0 for 1, for 2 it would be 2C0 plus 2C2, and for 3 it would be 3C0 plus 3C2, and 5 it would be 5C0 plus 5C2 plus 5C4, which turns out to be 128. Alright. Now again this is the result, guys. like I have calculated it here. Let's see this. The number of ways to select 5, let's say, to select 5, 5, 5, 5, 5, 5. There are 5 5s here. It is 5c0 plus 5c2 plus 5c4. Its total number of ways is 16, which correspond which simply again is that same result, which is power of 2 to the, which is how many 5s are there? 5 minus 1, 5 minus 1, which is 16. So total number of ways to select even number of 5s from 5 5s is 16. This is the exact same code that I wrote here. Now let me just quickly walk you through the code. This is a standard procedure to calculate the power where the base and exponent is given. I wrote this to ensure that the mod does not create any problem, since the question wants me to answer to this modulo. And yeah, let me just walk you through the code real quick. Yeah, first I made a map. And then which tracks the frequency of all the elements which have been provided to me, and then I initialized all the variables, and then I created a set, and from that set I created a vector b, which is just basically removing the duplicates from a, and in b I checked how many adjacent pairs I have. This number of adjacent pairs I stored in this variable. After this, from the map, I iterated through all the elements, and if the value of the element is -1, which is this, since I don't want to get the number of -1s in here, because I only want to get the number of equal pairs of positive values, so I continued this part. After this, ensuring that the mod is correct, I calculated the power of frequency minus 2 to the power of frequency minus 1, and multiplied it to my current variable, multiplied it to my equal variable. And then in this, what I checked here is that if there is no -1, because I am going to access the frequency of map -1, if there is a -1, if -1 exists in my input array, which is this one, then I calculate even odds and odd odds, even ones and odd ones. Number of ways to get even ones and odd ones, what we saw in the result was same. Here it was the same thing, same value, so that exact same value I calculated here. If -1s exist, then the number of even ones would be 2 to the power of frequency of 1 minus 1, frequency of minus 1, and since odd ones and even ones are both the same values, I just set this to the same value. If the given array does not contain any -1, I would say the number of ways to pick even -1s is 1, and the number of ways to pick odd number of -1s is 0. How can I pick the even number of -1s in this case? I can pick no -1, which is 0 -1, which is 1c0, so which gives me ways to select even number of -1s as 1. Now, according to this formula, I just wrote here this formula, ways through even numbers of -1 and the ways through odd number of -1s, and I wrote this formula here. This formula is for even and this formula is for odd, and then I just added and returned the answer. That's it, guys. Let me just also quickly run this one. Passed. So this was it, guys. The contest went fine according to me, I guess. Yeah, there is one more thing. You need to take special care of mod. Like, for example, what I did in this one here, what I did in this run where I failed in test case 9, my mistake was I added before applying mod. Here I added before applying mod, which is a mistake which might cause an integer overflow, and it did in my case. So I would recommend you to first multiply and then add, and then return your answer. That's it. This way you would likely not approach any problems with your integer overflow or something while returning an answer with a mod. That's it, guys. Thank you for watching. Let me end this real quick. Bye.